Hey everyone, welcome back to the channel. Today we are breaking down something super important in architecture, the one bit full adder. Whether you're a student, tech enthusiast, or just curious, you are going to love how simple this really is. Okay, so what is a one bit full adder? Well, a one bit full adder is a digital circuit that adds three binary digits, two actually two actual input bits A and B, and a carry in bit, which is this C in a carry in bit, okay, which comes from previous addition step. It then gives you two outputs, the sum bit and a carry out bit. I got this sum bit and the carry out bit. I'm gonna label this because yeah, let's take it back. So which goes into the next stage. Okay, so today I want to show you how it works by simulating it for you to understand. So I want you to watch this too carefully. This sum, let me just name it for you guys so you can, let's take this two output, the sum and the C out. Let's check it out. So if I turn this off, okay, I turn this switch off, I turn this switch off, right? What the output here is 1. The input I have in A and B is both 0, yet the output is 1. Okay, but then what happens if I turn on A? The output is still 0. Yes, the output is still 0. What if I turn off A and turn an input 1 into B? The output becomes 1. The output becomes 1. You see it? Check it out. Okay. So what happens if I own both A and B? Okay, here becomes 1, but here becomes 0. If A is 1, B is 1, here becomes 1, but here is 0. You get it? Looking at it well. Okay, that's good. And then if I also turn on this, here becomes 1 and here is still 0. Let's see if I turn off B and leave C in and A. Here becomes 1, here is still 0. What if I turn off A and leave only C in? Here becomes 1, here becomes 0. So the output of, let me just make this sum and C out so you can make it understand it fully. Um, okay, so there we go. So you see that the C out here tends to 0 and here's 1 when only the C input has inputted 1. Okay, so this is basically the demonstration. Okay, so that's it. Now let me dive into explanations for you to clearly understand this. So these two actual inputs have inputted as I showed before. It gives me 1 when all is off. When I input A to be 1, here becomes 0, here becomes 0. If I input B and A to be 1, here becomes 1 and here becomes 0. What if I input C in to go to be 1? Here becomes 1, here becomes 0. If I input A to be 0, here becomes 1 and here also becomes 1. Both of them becomes 1. If I input B to be 0, here becomes 1 and here becomes 0. What if I input C to 0? Here is still 1. You get it? So the C input depends, the input is required gives a normal output. Okay, so how does this work? Okay, let's say you want to add these three bits A, B, and C in. The one bit full adder adds it adds them just like a regular addition, but in binary. You get it? It adds them just like a regular addition, but in binary. Okay. The components used is basically important. The components used here are X and XOR gates, two XOR gates, and just take two XOR gates, two OR gates, three AND gates, one MUX, then two candles, one inverter. Okay, you can also build this using two half adders and an OR gate. Okay, so let's dive into the functions for you to understand this a little better. So the main use of this one bit full adder is binary addition with carry. It's used to create a multi-bit adders like 4-bit or 8-bit adders by cleaning several full adders together or by chaining several full adders together. Okay, arithmetic logic units like ALU. Have you all know the ALU? I'm sure. The calculators, the data counters, microprocessors, and more. Okay, why is it important? The full adder is a building block for all complex arithmetic in digital systems. Without it, we won't have computers being mad. Well, no, I don't think so. And that's the one bit full adder, small and but mighty. If you find this helpful, give me a thumbs up and don't forget to subscribe for more tech tutorials. See you in the next one.